Very good morning, students. Welcome back to online class on programming for problem solving course. In our previous session, we have completed the control structures. We said the control structures, they are of two types. The first one is conditional branching statements, and the second one is looping statements. Both the things we have completed. Different conditional branching statements we discussed, like the if statement, if else statement, nested if else statement, if else ladder, and also the switch case statement. So the looping statements, we discussed about the three different types of loops in C language. That is while loop, do while loop, and for loop. So the loops, we said they have been divided into two categories. That is pre-test loops or post-test loops. Pre-test loops and post-test loops. Your and there is another categorization in your loops. We categorized them like counter controlled loops and event driven loops. So all these things which we discussed in our previous class or previous session. Okay, so in today's session we'll be starting the uh, important concept, one of the important concept, that is a data structure as well. We we can discuss more about these data structures in your uh, third semester, that is in your 2-1. But over here we'll do a normal study related to these data structures, and your array is one such data structure. It is a linear data structure basically. Okay, so the concept of arrays we will discuss in today's session. So suppose the need for these data structure and the array, and the definition of this array, in order to understand, I will give you a simple example. So whenever you want to store some data inside your program, in order to store the data, what we are doing, we are declaring variables. Okay, we are declaring variables. If you want to store one data element into your program, you are declaring one variable. Okay, one variable, and that variable type, it depends on the type of data that you want to store into it. Suppose if you want to store the integer data, you are creating an integer variable. If you want to store the character data, you are creating the character variable likewise. So suppose if your number of data values that you want to store will increase. Suppose if you want to store 10 data values, okay, 10 integers, let us assume. If you want to store 10 integers, then definitely you need to create 10 memory locations. Okay, 10 variables. Memory locations are nothing but 10 variables, and those 10 variables will hold your 10 values. Okay, so to some extent it is easy. Okay, to some extent we can control, and the concept is handling the variables and maintaining the variables, it is an easy concept. Okay, to some 10 elements, to some 50 elements, okay, let us assume up to 50 elements also, it is quite common. Okay, but if the variable count increases rapidly, okay, if the variable count increases rapidly, like 100, 200 variables if you want to maintain, then what will happen? Definitely problems will arise. Okay, the maintenance of those variables into your program will become a difficult job for a programmer. Okay, how come? Means if you're creating like 50, 100 variables into your program, then you have to remember those 50, 100 variable names. First of all, it is a difficult job. Okay, it is a difficult job, and moreover naming them to some extent, even if you name them with English alphabets, we have like up to A to Z only. Okay, if you give some lengthy names, then remembering those lengthy names will become a difficult job, isn't it? So because of that reason, the programmers, they thought that maintaining different names for different variables, it is not a wise job, it is not an easy job. Okay, so what they have done, so simply, instead of giving a separate name for a separate variable, they started grouping the variables. They started grouping the variables, and your arrays is one such group only. Okay, one such type of group only. So we have different ways in which we can group the data variables. Okay, your arrays is one such type. So quickly you just read out the points over here. Okay, the same thing, the concept what I explained to you so far, that same thing is in terms of points you can see over here. See, if we have to read, process and print 10 integers, then we need 10 integers in memory for the duration of the program. Okay, we can declare and define 10 variables with 10 different names. To read these 10 variables from the keyboard, we need 10 read, that is scanf statements, and also to print these 10 variables onto the output screen, we need another 10 output statements, that is printf statements. This is something redundancy in programming code. Redundancy means repetition. Okay, having 10 variables, reading 10 values and printing 10 values, it is if you do in a normal way without using arrays, if you do it in a normal way, it is a redundancy job. Okay, repetitive job we can say. Okay, so how we can avoid this one means, this approach may look simpler and acceptable to some extent in the sense if the variable count is less. Okay, if you have like 10 variables, 20 variables, to some extent it will look simpler and acceptable. But if the variable count increases rapidly, okay, nowhere the above concept is acceptable. Yes, if the number of variables that you are going to use in your program, if they increases rapidly, we cannot go in a conventional way, that is in a traditional way, that giving a different name for different variables. Definitely we have to look for a suitable approach, a simpler approach, and wise approach we can say. Okay, to process large amount of data, C uses a powerful data structure called array. So as I said, it is a data structure. When we are saying arrays, they are data structures. Okay, and C uses this arrays in order to maintain the large amount of data in your program. So if the variable count increases rapidly, if you have more number of variables to store in your program, definitely you have to go for arrays, because using the normal approach you will be lost. Okay, you will be lost. An array is a collection of elements of same data type. Here the definition of the array is given. What is it? An array is a collection of elements of same data type, or we can say array is a collection of homogeneous data element. Homogeneous means same data elements. So this definition you need to remember. Okay, what is an array? Definitely more number of times they ask this question about arrays. So an array, it is a collection. So when I'm saying collection, it is not a single entity, rather it is a group, isn't it? So if it is a group, then only we term it as a collection. Otherwise we call it as a normal entity. Okay, an array is a collection of elements of the same data type, and we are saying they are of same data type. So if you are creating an array of integer, then you can store only integer variables. If you are creating an array of character, then you can store only characters into that array. We cannot store the mixed data type elements into the array. Okay, if you are creating an array of integer, then you can store all integers only into that array. Okay, so it is not possible to store the mixed data elements or mixed type of values into an array. Mixed type of values in the sense, some values of integer type, some values of character type, some values of float type, like that we cannot store. All values, they should be of same type when you are storing inside an array. Okay, array elements can be initialized, accessed and manipulated using the indexing. So first of all, we need to know how we can create an array. So I will show you how we can create a normal variable, and then I will show you how to create an array and how we can access the individual elements from the array. So that entire concept I will explain over here. Okay, so let us say I want to store only one value of type integer into my program. I want to store only one value, that is 20. Let us assume I want to store only one value 20 into my program. So what I have to do, I have to create only one variable of type integer. So that is how I can define, give the name. First of all, we need to give the name, that is declaration. So A is my variable name. Okay, and I need to define the memory, that is integer. I want to store integer value into this variable A. So A of type integer, and how I can put the value into it, that is 20, assign using assignment operator 20, like this. Now this a is will be in your memory, and it is going to hold the value 20. It is going to hold the value 20, like this. This is only one memory location when you are creating a primitive data element. This will be only one memory location, and in that memory location we have stored the value 20. So this is how we create only one variable. Suppose if you want to create an array, then array will be created. The declaration of the array, you see, array will be created. First of all, you have to give the name, and you have to use the index. Index you have to put in between the square brackets. Index you have to put in between the square brackets. Here what we do, so we provide the size. We provide the size here. So here you have to provide the size. This is your identifier. Identifier is nothing but the name using which we are going to identify this element. This is your identifier. This is the size and this is the identifier, and here also we need to specify the type. So here I am storing the integer type of element. So the type of this array will be int. Okay, the type of this array will be integer. Okay, then yeah, so I will give you the example. So this is how we declare and we create an array. Okay, I will give you an example. Suppose if I want to store 20 elements, so 20 is too long, right? So if I want to store like 10 elements or 5 elements, let us assume, we will take this small example, and I will demonstrate with the help of pictures and all. Because if I take more number of elements, I need to draw a lengthy array, a big array that I don't want. So that's the reason I'm taking a small array with 5 elements. So array, how I can declare an array of 5 elements? Give the name a and put the size 5. So now this variable, when I have created, it will allocate only one memory location, and you can store the value into it. But when you create an array like this, when you create a collection like this, it will allocate how many elements, how many memory locations? It will allocate 5 memory locations likewise. 1, 2, 3, 4 and 5, like this. Okay, so how many memory locations we got now? We got 5 memory locations. So now how many values I can store into this array? I can store 5 values, because my size of the array is 5 values. 5. Okay, so I can store 5 values. Let us say I'm storing the values here. I will show you how to store the values. 6, 9, 3, 2, 1. Like this, I'm storing some random values. Okay, now how I can access, because whenever I want this 20 value into my program, in place of 20, what I am keeping, I can keep a, because a is holding 20. So I can keep a wherever in my logic processing, wherever in my program, if I need the value 20, I can keep this a. So that a will give you the value from this memory location, from this variable location. Okay, but in case of an array, if it is an array, how you can access the individual elements from an array? How you can access the individual elements from an array, in the sense using index. We call it as index. Using index, we can access the individual values from the array. So what is the index? Okay, so declaring the array like this with 5 elements is allocating 5 memory locations, and these 5 memory locations you can access with the help of the identifier followed by index. So this is how you can. So you have to put the index value in between the square brackets. So this is identifier, and here you have to give the index value. So index, how the compiler will allocate for these memory locations, in the sense, the first memory location, always in your array, the first memory location will take the 0th index. Remember this one. And remaining all will be in sequence. From 0 it will start, the index will start from 0, 1, 2, 3, 4. So you can say the index of an array will start from 0 and ends at maximum size minus 1. Maximum size minus 1. Always the array index will be like that only. It will start at 0 and ends at maximum size minus 1. So to my array, what is my array name? A. And what is my maximum size? 5. 5 elements I want in my array. So what will be the index? The index will start at 0 and ends at maximum size minus 1, that is 5 minus 1 at 4. So now how I can access all these individual elements from my array, in the sense, the first element will become, so I have to put the identifier followed by the index, isn't it? Like this I have to put identifier followed by the index. Like this I have to put. So the first element in my array, it will be the index value. First I have to put the identifier, and in between square brackets I need to take the index, that is 0. So like this. The second element, it will be a of 1. The third element, it will be a of 2. So like this, all elements you can access into your program. Okay, a of 2. Then this element, a of 3. And finally the last element, a of 4. So like this. Suppose if somebody will tell you, if somebody told you that to add the second element and fourth element from your array. Okay, they're asking you to add the second element and fourth element from this array. What is the second element? Second elements, whenever I am saying second element, you have to take the index value, that element number minus 1. Always you have to. Second element in the sense a of 2 minus 1, that is a of 1 will be the second element, plus the fourth element in the sense a of 4 minus 1, that is a of 3. Like this. So what is a of 1? That is 9. Second element is 9, plus what is a of 3? That is fourth element 2. So like this you will get the value 11. Hopefully you understood. So always remember how we are accessing the array elements. With the help of index only we are accessing the array elements. Array elements can be initialized, accessed by manipulated using the indexing. Just now I have explained what is indexing, what is identifier and what is indexing, and how this identifier and index is helpful in accessing the array elements. I have explained. Okay, array index always starts at 0 and ends at maximum size minus 1, or total number of elements minus 1. Okay, remember this one, maximum size minus 1 or total number of elements minus 1. So in our example, so here I have created an array of 10 elements. The array name is scores. Okay, array name is score, and I have 10 elements into that array. So how the index will start for this array? Index will start at 0 and ends at maximum size minus 1, that is 10 minus 1, 9. Okay, that same thing I have explained over here. In our example, the index for score will start at 0 and end at 9. Okay, index will start at 0 and ends at 9, hopefully. Okay, so arrays, how many different types of arrays we have in C? Okay, so we have two different types of arrays in C. One is one-dimensional array and the other one is two-dimensional array. The first type of array we call it as 1D array, because it is one-dimensional we call it as 1D array, and the second type of array, as it is two-dimensional, we call it as 2D array. Okay, so in one-dimensional array the data will be organized linearly. So linear in the sense only in a row. Likewise, all elements, even if you take 100 elements, all these 100 elements will be consume the memory linearly. All these elements will be stored linearly like a row. Okay, all the data will be organized linearly in only one direction. We are not going to have multiple directions over here, only in one direction, and the data will be stored linearly. Okay, but in a two-dimensional array the data will be stored in rows as well as columns, like a matrix. Okay, you may be aware of matrices in your mathematics. So over there in your matrix we are going to have rows as well as columns, isn't it? Rows as well as columns. So here also in a two-dimensional array we are going to have both rows. These are my rows. How many rows? 3 rows. And then columns. How many columns? 2 columns. 3 rows, 2 columns. Okay, for this we are going to use the index 0, 1, 2 and so on. Over here we are going to have the index for both, for rows as well as for columns. We are going to have indexing for both. Okay, so first we will discuss about the one-dimensional array more clearly, then we will go for two-dimensional arrays. Okay, so one-dimensional arrays. Okay, so how we can do the declaration and definition of a one-dimensional array, that we will discuss. So like every other object. So whatever objects, whatever elements we are going to use in our program, whatever programming constructs we are going to use in our programming, we must have to do these three things. I already told you in case of variables, when we have done these three things, I told you over there itself, this is not only for variables but all other programming constructs. We do the declaration, we do the definition, and we do the initialization. So for an array also, we have to discuss how we can do the declaration of an array, and how we can do the definition of an array, and how we can do the initialization of an array. These three things we have to understand before we can use these arrays into our programs. So array declaration tells the compiler the name of the array. So declaration means what we are doing? We are doing the name. We are giving the name to the array. So declaration, what it will do? It will give the name. And definition, what it will do means it will specify the size or number of elements. How many elements we want, how many and what type of elements we want, that will be specified by the definition. Okay, and uh, okay, so in a fixed length array, more probably we are going to use the arrays of size fixed length only. So in a fixed length array, the size of the array is a constant. Always the size of the array will be the constant value. So at the time of creating the array only, you must decide how many elements you want into that array. Okay, you cannot do it in your program logic, or you cannot do it later when you are executing the program. So when you are creating the array, at that time only you have to finalize the size of the array, that I need 10 elements or that I need 20 elements into my array. At the time of declaration only you have to finalize the size. So because of that reason, we are saying the in a fixed length array, the size of the array is a constant, and you must have a value at the time of compilation. Is before the execution, before seeing the output, before checking the output. At the time of compilation only, the size of the array must be decided. So how we do the declaration and definition of an array? Here what we are doing, we are doing two things. The declaration means we are giving the name to the array. So that is declaration. Okay, when you give the name to the array, we call it as an declaration. Or and specifying the type and specifying the size, we call it as definition. Okay, so what is definition? Specifying the type and specifying the array size is nothing but definition. So these two things comes under definition. So so the declaration of the declaration and definition format for a variable length array is same like a fixed length array, except the size is a variable. The array size will be determined when the program is executed. Yes, see here. So generally think of it in this way. We are going to have two types of array. In one dimensional array also we are going to have two types. One is fixed length and other one is variable length. And as the C programming language supports only fixed length arrays, we are not touching the concept of variable length arrays. We are not going for variable length arrays. Variable length arrays, it is not supported in your C language. You must have the size, I mean fixed size of an array at the time of compile time. So because of that reason, we will not touch the variable length array concept. Rather we will discuss only fixed length arrays in our subject. Okay, the array size will be determined when the program is executed. Even if it is decided at the time of execution, but we are not going to have any control on the program at the time of execution. It simply takes over the control and it starts executing, and it will show us the output. Okay, we are not going to have any control at the time of execution of the program. So because of that reason, our arrays, we are making them like fixed length in C programming. Okay, so fixed length in the sense, at the time of compile time only you have to know the size of the array. So if you declare the array like this, so over here you can see uh, int scores of 10. So this is the size of the array, this is the name of the array, and this is the type of the array. Okay, so name is scores, and I need 10 elements into this scores array, and all should be of type integer. Okay, all should be of type integer. So if I do the declaration in such a way, how my array will occupy the memory in your computer memory, in the sense like this. And you can see the indexes that also I have shown over here. This is 0th index, first, second, third, fourth, fifth, 6th, 7th, 8th and 9th. And how I can access all individual elements from this array in the sense with the help of indexing. So what should I have to write? Scores of 0 will give you this element. Scores of 5 will give you the 6th element. And scores of 9 will give you the last 10th element likewise. So simply we have to use the array name to access the array elements. We have to use the array name followed by the index, and index you must have to specify between the curly brackets. So if I put scores of 3, this will give you the 4th element. Okay, scores of 3 in the sense this particular element, and this particular element when we are talking about, it is 4th element because this is 1st element, 2nd element, 3rd element, 4th element. This is not something I'm writing indexing over here. I'm writing the element count. The indexing is different. Indexing at the bottom we have shown. This is the element count. The first element is this one, second element, third element, fourth element. Likewise, in order to access the 4th element from the array, you have to supply the index value 3. Okay, you have to supply the index value 3. The reason, because the index will start from 0. So 0th element, 0th index element will become the first element. First index element will become the second element. Likewise, third index element will become the 4th element in your array. Okay, so how we can access means with the help of a for loop and with the help of a printf statement, normal printf statement, we can access the elements from the array. So always remember, whenever you are accessing the elements from the array, the index value plays the important role. So over here what we are doing, I'm taking this printf statement inside a control structure, that is inside a looping statement, that is for loop. So this for loop, how it will operate, I will tell you over here. First, always in every loop we said we are going to have 3 things, that is initialization, condition and updation. Okay, the initialization part, it will be done only once for every loop, for every for loop. Initialization part, how many times it will be done? Only once. So I value will be initialized to 0. Then we have the condition part. Condition will be tested. Okay, condition will be tested. So condition 0 is less than 10. Condition is true. So then what will happen? If the condition is true, the body will be executed. So this body, this printf statement, printf is something, it is like an output statement, output function. So what it will do, it will print the value of whatever you are passing. It will print the value whatever you are passing to that function. So printf of %d, %d, it is a control string, and this %d, it will be used for integers. %d for integers, %c for characters, %f for float and double. Likewise, you have to remember these things. Okay, so printf function we are using, and scores of I, that is nothing but initially I value is 0, so scores of 0. So this will print the 0th element, 0th element from your array, the first element from your array. Okay, 0th index element, that is nothing but the first element from the array. Likewise, after executing the body, again the control will come back, and it will do the update. It will do the update. Update means I value gets I plus plus means what? I told you at the time of discussion of increment and decrement operators. I plus plus is nothing but I equals to I plus 1. So I value gets incremented by 1. So now I value is 1. So when I value is 1, again the condition will be tested. This time after updation, only the condition will be tested. It will not do the initialization again. It will not do the initialization again, only it will test the condition. So 1 is less than 10, condition is true again, because I value is 1. So 1 is less than 10, again the condition is true. So what will happen? It will go and it will execute the body. So scores of 1 this time. Already scores of 0 it has printed. Whatever value you are going to have at scores of 0, that value it has printed. So let us take the example over here. I'm keeping some values over here. This is 4, this is 1, this is 2, this is 5, this is 9, this is 7, this is 6, this is 3, this is 2 again, this is 9 again. Okay, like this I have taken all 9 values. So first scores of 0 it was printed, so 4 it has printed on the output screen. Then scores of 1 it is printing now, because scores of I value is 1. So scores of 1, what is the value? Scores of 1 is 2. So the 2, yeah, scores of 1 is 1 only, that 1 it will print. Okay, Next thing, again after printing, again it will go to the update and it will update the I value. So I value is 2 now. Okay, I value is 2 now. So the 2 will be tested with 10. So 2 is less than 10. Again the condition is true. So again it will go to the body. Then scores of 2. What is scores of 2? Scores of 2 is 2 only. So it will print 2 on the output screen. Then again it will go to the I++ and increment the I value. So I value this time it will become 3. Okay, I value get updated, I value becomes 3 now. Then again 3 will be tested with 10. 3 will be tested with 10 and it will print it is true. So it will print scores of 3. What is scores of 3? Scores of 3 is 5. So it will print 5. So likewise it will print all the elements. After 5 we have 9, 7. So scores of 4, 9. Scores of 5, 7. Scores of 6, 6. Scores of 7, 3. Like this it will print all the values. So scores of 8, 2. And then it will print scores of 9, that is 9 only. After printing this 9 last element, what will happen? Just check. After printing the last element, okay, when it is printing the last element, the scores the I value will be 9, because of that reason only it will print scores of 9. Okay, scores of 9 is this last element 9 that we have printed. Okay, after printing scores of 9, again I value gets updated. So this time I value gets updated and I value will become 9 plus 1, that is 10. Okay, and then what we are doing, we are checking the condition. Just check the condition. 10 is less than 10, condition is false. We are saying 10 is less than 10, so the condition is false. So immediately what will happen, the control will come out of the loop. It will not go to the body and it will simply come out of the loop. So in this way we can print all the elements from your array starting to end, all the elements. If you have 10 elements, just put 10 over here. If you want to print 100 elements, just put 100 over here. Likewise, you can access all the elements from your array with the help of a simple for loop. Okay, hope you understood this one. So then storing the values into an array, uh, that is nothing but the initialization. Storing the values is nothing but doing initialization, and this initialization we can do in 4 different ways. The first one, basic initialization approach. The second one is initializing without size. The third one, partial initialization. And the fourth one is initializing all elements to zeros. It is a 2 marks question basically. Okay, about initialization, first one is basic basic initialization, initialization without size, partial initialization, and initializing all elements to zeros. So I will explain that one over here. So suppose if you have a normal integer element, integer a is equals to 20. So this is how we are declaring, defining, and initializing a normal integer variable. But if you have an array, if you have a collection, if you have an array, so how we deal with these arrays, in the sense, because it is going to have more number of elements. So int a of 5. So to initialize these a of 5, one approach is we can do the initialization individually. So individual elements we can initialize. That is, we can do like this: a of 0 is equals to 2. So this will create 5 memory locations. Okay, this will create 5 memory locations: 1 2 3 4 5. So this is your 0 1 2 3 4, like this. So a of 0, I'm saying 2, so this 2 will come and reside over here. Then a of 1 equals to 4, like this I can say. So a of 1 4, so this 4 will come reside over here. Then a of 2 7, I'm saying, so this 7 will come and reside at a of 2. So this is my a, basically this is my a, an array. Okay, then a of 2 7 we have stored. Then a of 3 I want to store 9, so that 9 will come and reside over here. Then the last one, a of 4, I want to store like 6, so this 6 will come and reside over here, like this. So this approach, in this way you can store all elements into your array. Okay, this is we called initializing individual elements. We call this approach as initializing individual elements, because we are initializing all elements individually. Okay, initializing individual elements. Second approach is initializing all elements, basic initialization. Second approach is basic initialization. So we can pass all values like a set over here. Maybe you know the meaning of a set from your mathematics. Set in the sense it is a set of values. So basic initialization. How we do basic initialization is, so just take the array. First you do the declaration, that is array name followed by the size. I want a of 5 is the size, that with int equals to, so here I want 2 4 7 9 6. So now what will happen? The same thing, you will get the memory and 6 elements, oh sorry, 5 elements. First element 2 4 7 9 6, like this it will do the initialization. This is your index 0 1 2 3 and 4. This is basic initialization. All elements you have to pass like a set. Okay, all elements you have to pass like a set, so it will do the initialization like this. So next thing is initializing without size. So initializing the elements without the size. So that is, just take the elements, initializing without size. So how we do this one in the sense, just take int, don't put the size, a of. So when you don't put the size, whatever number of elements you are going to initialize, that many memory locations will be assigned. Okay, that many memory locations will be assigned. Suppose if I pass over here only 3 elements, 2 4 7. So how many elements I passed? Only 3 elements I passed. So how many memory locations it will reserve? Only 3 elements it will reserve, that is 2 4 and 7. So it will make that, I mean it will make that array size by just counting the number of elements that you passed. So if you don't give the array name, this type of thing will happen. Okay, if you don't give the array name, this type of thing will happen. Sorry, array size, this type of thing will happen. So next thing, if I give, I mean in another statement what I am doing, I am creating another array int b of, and in that I am keeping like 2 7 9 4 3 8 5, like this. How many elements? 7 elements total. So how many memory locations it will allocate? It will allocate 7 memory locations for this array. Okay, so first 2 7 9 4 3 8 and the last element 5, like this. Okay, so this will become 0 1. Index will start at 0 and end set maximum size -1. So maximum size is 7 because we took 7 elements, so, and it will end at 6, maximum size -1. So like this, hopefully you understood. So this is initializing without size. So if you don't put the size of the array, then what will happen? The size of the array depends on the number of elements you are passing. If you pass 3 elements, the size will become 3, and if you pass 7 elements, the size will become 7. Likewise, whatever number of elements you are initializing, that much of size of the array you will get. Next, the partial initialization. Okay, if you don't want to initialize all the elements, you have given the fixed size but you don't want to initialize the all elements, that is partial initialization. So here what I am doing in the sense, I am taking an array int a of 5. Okay, so how many values how much size I have taken? 5 elements I have taken, but I am passing only 3, let us assume 2 4 7. Here I have given the size, so this time it will not check the number of elements, it will check the size. So as you have given the size as 5, so how many elements it will reserve? How many memory locations it will reserve? 5 memory locations it will reserve. So the first one 2, second one 4, third one 7. Then what will happen with the rest of the 2 means it will put zeros, because you have not passed any constant values for them. You have not given any constant values for those 2 memory locations, so the compiler will automatically initializes these 2 elements to 0. So now how the index? This is 0 1 2 3 4. You will have 5 elements. First 3 will be 2, 4, 7 because you passed 2, 4, 7, and the last 2 will be 0. Okay, in this way. Okay, so some student asked me that if I want the starting 2 as 0 and I want the last 3 with some values, so is there any approach to do in partial initialization? In the sense, no, you can't do in that way. So whatever values you pass, they will occupy from the beginning only. So if you want in that way, if you want the first two zeros and then 2, 4, 7, how you have to do? Int b of 5, okay, equals to, put two zeros in the beginning, then 2, 4, 7. So now how the allocation will be, how the initialization will be? So it will also take an array with 5 elements, and this time the first two it will initialize to 0, then 2, 4, 7. In this way you have to do. If you want your first two elements to be 0 and next as the constant values what you assign, then directly in this way you can't go, because if you go in this way, these 2, 4, 7 will occupy only the starting 3 locations. So if you want starting locations as 0 and then the constant values, means you have to go in this approach. Okay, this is the partial initialization. If you don't initialize, I mean if you don't pass the sufficient values for the array, uh, then what will happen? Whatever values you are missing, I mean whatever location values you are missing, whatever location values you have not passed, those location values will be initialized to zeros by the compiler. Hopefully you understood. In the last approach, if you want all elements to be initialized to 0, that is initializing all to zeros, initializing all to zeros. So if you want all elements to be initialized to 0, then how you can do? Int a of 5. No need to give 5 zeros, just take like a set and put only 1 0. That's enough. It is a shortcut method, we can say. Yeah, 5 zeros also you can put, it will also give the same output, but over here as much as possible we have to avoid the redundancy, and as much as possible we have to avoid the key presses in our program. So if you give 5 zeros, it will take more key presses, isn't it? But if you give only 1 0, it is like a shortcut and it will take less key presses. Okay, keystrokes, we call them as keystrokes. Okay, a of 5 equals to 0, it is it will give the same meaning like doing. Yeah, over here what will happen? Your 5 elements you will get, and all 5 will be initialized to zeros over here. 0, 0, 0, 0, 0. And yeah, the other approach is what? The other approach is int a of 5 equals to 0 comma 0 comma 0 comma 0 comma 0. This will also give the same output. Okay, so this will also takes 5 elements, and those 5 elements will be initialized to zeros. Here 0, 0, 0, 0, 0. So this means this and this, they both are same. This and this, they both are same. So here the index 0, 1, 2, 3, 4, and here also the index 0, 1, 2, 3, 4. Okay, so one question over here. Okay, just put this here. One question. So if I do the initialization like this, int a of 5 equals to 2. So is it similar to partial initialization, or is it similar to initializing all to 2's? Yes, the answer to this one is this is similar to partial initialization. This is not something initializing all to 2. Okay, remember this one. See, when it comes to initializing all elements, you can do all to zeros only. That's the reason we are saying initializing all to zeros. We are not saying initializing all to a number, isn't it? We are not saying initializing all to a number. We are specifically saying initializing all elements to zeros. So this is when you do like this and expect all elements to be initialized to 2, it will not happen. Okay, this is something going with partial initialization. So how the allocation will be done over here in the sense, yeah, it will take 5 memory locations. 1, 2, 3, 4 and 5, and the first will become 2 and rest of all they will become 0. This is the concept of partial initialization. So what it is, how it will be. One more question. Int a of without size, and I'm keeping 2. So now how many elements? What how many memory locations you will get, and how many memory locations will be initialized to 0, and how many memory locations will be initialized to 2. So for this comes under initializing without size. The concept initializing without size we discussed. So if you don't put the size, you will get only the number of constant variables that you passed, only the number of constants that you passed. So the array size will become only one element, and that element will be initialized to 2. So to access this one, what we have to do, you need to put a of 0. So this is 0th index. So over here this is 0, 1, 2, 3, 4, like this, the index values. Hopefully you understood. So all 4 different concepts we discussed. Basic initialization, where you need to pass the exact number of elements equal to the size of the array. Okay, initializing without size, we are not passing the size, and the compiler itself counting the number of constants that we have initialized, and it is automatically creating an array. It is automatically allocating the memory enough to store all these elements, or enough to store all these values. If you are passing 5 values, it is allocating 5 memory locations. If you are passing only 2 values, it is allocating only 2 memory locations. So this is initializing without size concept. And then partial initialization, yes, you need to initialize the elements partially, and rest of the elements they will take zeros. Okay, then initializing all to zeros is like this. Array size of 5 elements we have created, and we are simply passing only 1 0, and that is enough. All my 5 elements will be initialized to zeros. Hopefully you understood. Okay, then inputting values, reading values into an array. Just now we discussed printing values. Printing values with the help of printf we have done, and reading values with the help of scanf we do. Okay, scanf. So how means same thing. The array index will start at 0 and ends at maximum size. Okay, so this array, it is going to take, here it should be 10. When we are saying less than, here it should be 10. So what will happen? First it is reading scores of 0. Okay, so the compiler, the control will wait on the output screen to input one value. Then it will read scores of 1, scores of 0, scores of 1, scores of 2, scores of 3. Likewise it will read up to scores of 9. So 0 to 9, total 10 elements it will read. How many elements it will read from the keyboard? It will read 10 elements. So when you read the scores of, when the I value becomes 10, when I value becomes 10, then what will happen? This condition will fail, because we are saying 10 is less than 10. So this condition will fail, and it will come out. It will come out. I mean, it will not read any more elements, and it will simply come out. Hopefully you understood. So in this way, we are going to read the elements from the keyboard. So initializing, inputting value in the sense reading the values from the keyboard. Okay, to read the values from the keyboard, we use a predefined function scanf. So print the values, we are using printf, and reading values we are using scanf. Okay, then assigning values also, we can do the individual initialization. Okay, we can do the individual initialization of elements. Okay, and see, expecting two arrays, this is an important concept that we need to discuss. So we have two arrays. Let us say the first array I am doing like this: int a of 5, and I am initializing the values something like this: 24971 So now how this array will be, how the memory allocation will be, you will get the array like this, and 1 2 3 4 and 5. So this will become 24971. So this is your 0 1 2 3 4. This is how I have created one array, and I'm creating another array, and I'm not doing the initialization. Int b of 5, and I have not done initialization. So if you have created like this, what will happen? It will be like 5 memory locations uninitialized. Okay, 5 memory locations: 1 2 3 4 5. Okay, this is 0 1 2 3 4. This is my A array, and this is my B array. Okay, so can I do the initialization like this? I mean, I want to copy whatever elements I have into my A array. I want to copy all these into my B array. Into my B array. Can I do like this? B is equals to A. Can I write like this one simple statement and expect all these values to be copied into this? Means no. This is not a valid statement, because the array name, when we are taking, it is an identifier, and all array elements, they must be accessed using index. We made this rule, isn't it? We made this rule. This is not a normal variable. When we are saying A and B, this is not a normal variable. They are arrays. Okay, they are arrays, and whenever we have an array, we cannot access the elements from an array by simply taking the identifier of the array, like your variable. For your variable, it is okay when you are doing the declaration like this: int a is equals to 2, and doing int b, and b I'm not initializing, and b is equals to a I'm saying, and I'm expecting a value to be copied into b. A value, how many memory locations? Only one memory location, and it is holding 2. B value, how many memory location? Only one memory location. So after this, what will happen? B value will also become 2. So doing like this, it is okay in case of a normal variable, but in case of a collection, in case of an array, you can't do like this, because array name, when we are saying, you can't use simply the array name to access the individual elements, because when we are talking about array name, it is more than an identifier. It is more than representing value. It is the address basically. So we deal with pointers in your 5th unit. There you will understand what exactly the array name, and why we are calling the array name as the address. Okay, over there you will understand. So for now, you simply remember the array name. It can't be used to access the only the array name. It can't be used to access the individual elements from the array. Definitely you have to go for the indexing. So here, whatever operation we are performing, the assignment operation we are performing, we are doing without index. So doing so is an error. So how I can copy this array elements into this second array in the sense? It is very simple. Take the for loop once again. For all, take the counter value I equals to 0, and I must be less than, how many elements we have in both the arrays? Only 5 elements. I must be less than 5. Then do the updation I plus plus. Then put b of I, only one statement, so no need to use the curly brackets. B of I equals to A of I. See, if you regularly follow my classes, you will understand the coding, you will understand my terminology. If you're missing my classes, if you're not attending my classes, and suddenly at some point you're attending my class and you're expecting the things you will to understand, it is not possible. Okay, definitely you need to follow all the videos, you need to watch all the videos, then, because we are clearly seeing, because only few of the students, they are paying the attention towards the classes, they are attending on all the lectures. Okay, and many of them, they are not, because every video hardly I'm getting the even though I have created every video of 60 minutes, 1 hour I have created, for every video I'm hardly getting like 10 to 20 hours of watch time. It is very less, very less it is. Okay, so when I'm getting that much less watch time, I can easily tell that all the students, they are not watching, they are simply opening the video and they are posting the attendance and they are leaving, they're not watching the full video. Okay, definitely you will be at loss. I'm posting my videos and I'm doing my job, but you will be at loss if you're not going to watch the videos. Okay, so here b of I equals to a of 1. So what will happen in the first iteration? In the first iteration, the initialization part will be executed, then the condition part. Okay, in the first iteration, the control will come like this, and it will do the initialization. So I value will become 0, then it will check the condition. So I value is less than 5, 0 is less than 5, so condition is true. So what it will do, it will go to the body, it will go to the body and it will do b of 0, because I value is 0. B of 0 means this first location, equals to a of 0, because I value is 0. A of 0, a of 0 means this value, so this 2 will be copied into this location. Okay, 2 will come over here. So then after executing the body, the control will go to the updation part. The control will go to the updation part. So it will do the updation of I value. I plus plus means I equals to I plus 1. What is I plus plus? I equals to I plus 1. So we have I value 0. So 0 plus 1. So I value will become 1 now. Okay. So now the I value is becoming 1. So when the I value becomes 1, again it will checked. It will be tested with the condition. So 1 is less than 5. Condition true again. So it will come down B of 1. So this memory location. B of 1 equals to A of 1. A of 1 is this particular location. This will be copied into this. So here what you will get? You will get 4. Okay. So next thing, again it will go here and it will update I. So I will become 2 now. Okay. I will become 2 now. So I value is 2. Again condition tested, 2 is less than 5. So B of 2 is equals to A of 2. P of 2 is equals to A of 2. So this 9 will be copied into this location. Okay. 9 will come over here. So next thing, once again it will go to the control and it will updation and it will do the update. I value gets incremented. I value becomes 3. Then 3 less than 5, condition true. B of 3 is equals to A of 3. So that 7 will come over here. 7 will come over here. Next again the updation. I value becomes 4 at this stage. Then 4 is less than 5, condition true. B of 4 is equals to A of 4. So there is 1. B of 4 is equals to A of 4. So 1 will be copied over here. Then I value gets incremented once again. So I value become 5 now. So when I value is 5, it will come and it will test the condition. 5 before going to the body, it will come and it will test the condition. So 5 less than 5, condition becomes false. So it will come out. So when the condition goes false, the control comes out from the loop. In this way, the complete A array will be copied into B array. So in order to do so, you have to use like this. Simply doing like this is an error. You can't copy the one array into another array even if the sizes are matching. You can't copy one array into another array when you don't have when simply by using the array identifiers. Definitely you have to depend on the index like this. Hopefully you understood this one. Okay, the same thing I have explained over here. So then printing values, simple thing, we need to use the for loop with the printf statement. For reading values we are using scanf, and for printing we are using printf. Hopefully you understood. Okay, index range checking, this is another important point that we need to focus when we are dealing with arrays. So index range checking, that I will explain over here. So let us say if you have an array integer a of 5 equals to a of 5 equals to same thing I am taking 4 7 okay 9 2 1 2 1 something, some random values I have taken into this array. So how the memory allocation? Like this. Okay, we'll get 4, we'll get 7, we'll get 9, 2 and 1. So what is the index? The first element 0 1 2 3 4. So now whenever you are accessing the elements from this array, this is my A array. Okay, whenever you are accessing the elements from my array, from this array, so checking the index range is an important role. You should know whenever you are doing the logic processing, whenever you are creating whenever you are writing some logic on this array, you should be clear of the size of the array. So if you have the size as 5, how the index will be? The index will start at 0 and ends at maximum size minus 1, that is 4. The index will start at 0 and ends at, this is the starting point and this is the end point. So when you're reaching the end, you cannot cross that end. You cannot cross that end. So when you are framing the for loop for printing the values from this array, how we are framing? For all, we are starting with 0. I is 0, and when you are framing the condition, I must be less than the size of the array you have to write, that is 5. You should not put less than or equals to, or you should not put less than 6 like this. You should not put like this, because what will happen if you do like this? What will happen? The I value goes to 5 also. I value goes to 5 also. And if you are printing the value, printf percentile d comma a of I, like this we print the value of array. Okay, individual values from this array. So doing like this, so in the first iteration I value will be 0, so it will print a of 0, isn't it? It will print a of 0. So on the output screen you will get 4. Then the I value gets incremented, I value becomes 1. Because of this updation, I value becomes 1. Then condition will be tested, 1 is less than 6, condition is true. Then a of 1 we are printing, a of 1 will be 7, so that 7 will be printed. Next thing, I value gets updated after that, so I value becomes 2 now, so 9 we are printing this time. Then I value gets updated, 3 now, 2 we are printing now. Then I value gets updated, 4 now I value, so a of 4, that is 1 we are printing now. Then after this, when I value is 4, just come over here and test the condition. 4 is less than 6, condition is true. Okay, it has printed a of 4, that is 1 it has printed on the output screen. Then again the control will come back and do the updations. Over here when it is doing the updation, I value becomes 5 now, isn't it? I value is 5 now, and it will come to the condition and it will test the condition. 5 is less than 6, again the condition is true. Okay, at this iteration also the condition is true. Okay, if this condition is true, then what will happen? Again the control will come over here and it will try to print a of 5, which is a non-existing value. It is trying to print the a of 5. So a of 5, is it existing? After this, do we have any values? No, we don't have any values. We have up to the size 5 only, that is up index 0 to 4 only. If you try to access the index value a of 5, that is the 6th element into this array, we don't have that one because we are crossing the boundary. Over here the array limit, the array boundary we have, and we are trying to cross this boundary. So crossing the boundary is nothing but crossing the index range, isn't it? We are unknowingly what we are doing, if you simply take like this, we are crossing the array boundary or we are crossing the array index range. So this particular thing we have to take care of as a programmer. We have to take care of doing in this index range checking. Your compiler is not going to help you. Okay, being a programmer, you must take care of whether you're crossing the index range or not. And crossing the index range means going beyond the index. So when we have only 5 elements, the index will be 0 to 4, and accessing a of 5 over here is an problematic thing. Of course, it is not an error. Your compiler will not raise any error, syntactical error. It is a logical error, because you don't have that value, and if you put this a of 5 into your calculations, then what will happen? You will get garbage value, isn't it? You will get unknown value. So simply your complete program will get spoiled, isn't it? So that thing we don't want. So index range checking, your compiler is not going to help you. And being a programmer, the C language does not check the boundary of an array. So being a programmer, you must take care of this thing. You should not cross the index. So how we can means, only whenever you are framing the condition, when you are accessing the elements of the array, when you are framing the condition, you must make sure that you should not do any mistake. So if you have like 9 elements, okay, if you have, sorry, not 9, if you have like 10 elements, to access these 10 elements, the index will be 0 to 9. This you must know. Index will be 0 to 9. And whenever you are framing the condition, you must put I must be less than 10 only. Don't put I must be less than or equals to. Suppose if you want to go with 9, then I must be less than or equals to 9, one element less. Okay, like this you have to do. Like this you have to frame the condition. Don't put, these two are acceptable, this is acceptable and this is acceptable. Don't put like this, I must be less than or equals to 10. If you do like this, you're crossing the index. You're crossing the index, and it will give logical error into your programming. Okay, there is a simple program to calculate the sum of all elements of the array that we need to demonstrate. Okay, so hopefully in tomorrow's session we will discuss about two-dimensional arrays and also the strings concept. Only these two concepts we left with in your second unit, and hopefully I will complete these two in our next session. See this for two-dimensional array and a string, I need one class. And there is one more important question in this strings concept, that is string manipulation functions. This is very important question, and this is an LAQ, long answer question. Okay, long answer question, very important question. So this thing, a two-dimensional array and the concept of strings, C strings, we will do in one class. In tomorrow's class, hopefully I will complete both concept of strings and two-dimensional array. But string manipulation functions, again one more class. So overall, two more classes I need to complete the second unit. And as we committed, we are considering up to second unit for your first internal exams, hopefully. Thank you very much, students.